confusion. It was initially my big mistake of forgetting that this is actually not the regular semester. So we did not have our regular room available to us. But we're going to move forward with all of my mistakes. Anybody else still need handouts? Everybody have evaluation sheets and everything? Excellent. Okay, so today is going to be our last presentation of the semester. We will resume again the first week of class. So January 13th or so, I think. There are still several seminar slots available for people who need to give a presentation next semester. Send me a message. I sent out a list of the seminar slots that had been taken to all of the graduate students earlier in the week. A couple more have disappeared since then. And as is pretty typical, the ones towards the end of the semester are almost all gone now, but there's still plenty of opportunities in February and probably even early March. So if you still need to give a presentation or sign up for one, please do so. Also be thinking about titles and topics for your talks, because I will ask for those at the very early part of the semester, so that we can get everything advertised in the first week of class. Okay. So with that, I'd like to introduce Kaylee Faltys, who has been working with Nels Trollstrup on assessing freshwater mussels in South Dakota and identifying drivers of assemblage variation. She comes to us from a undergraduate at Wayne State in Nebraska. Do you want a slide advancer?
I can just use keyboard.
You sure?
Yeah.
Okay, all right.
Well, thank you for the introduction. So I'd like to start off by, first of all, thanking my advisor, Dr. Trollstrup, for all his guidance through this research project and letting me work on this very fun research. Also, my academic committee for their advisement and edits to my thesis. Also, my lab mates, Latasha, Aaron, and Aaron, who have got me through the hard parts but little things that matter during research and schoolwork. All of my wonderful technicians who I couldn't have done this research without, all the private landowners who allowed us access to streams through their land, as well as Fish Game and Parks and Ag Experimental Station for funding, and Oak Lake Field Station for facilities during the summer. So as many of you may know, we are in the 6th mass extinction, which is mostly caused by anthropogenic issues. And the highest extinction rate are those in fresh water. As you can see, this graph clearly depicts that freshwater invertebrates are at very high extinction vulnerability compared to terrestrial mammals and birds. And Unionidae mussels are at extreme vulnerability, as you can see on the left. They're, in the past 100 years, we've already lost 35 species of mussels to extinction. And of the remaining species, 70% of those are considered imperiled. In North America is the most diverse Unionidae fauna in the world. We have about 300 species native to the continent. And like I said before, they are declining fairly rapidly. And why are they declining? The mussels are very long-lived. Some species can live up to 200 years. And they're very immobile, so they can't move around a lot in their lifetime, which makes them very sensitive to any change in their habitat, as well as exploitation. In the late 1800s to early 1900s, freshwater mussels were heavily and commercially harvested for the use of pearls and making buttons out of their shells. And this caused devastating depletions. There's been an estimate that 11 billion mussels were harvested through this time period. And those effects are still seen in the streams today. As with any organism, habitat loss is one of the key components of their decline, as well as their unique life history trait. So Unionidae mussels require specific fish or set of fish hosts to transport their glochidia, or juvenile mussels, up or down the stream. And without these particular species of fish, the mussel will not be able to reproduce. Unions also provide a lot of ecosystem services. Dense assemblages of mussels can greatly increase water clarity because they are filter feeders. They're continually filtering the water. Dense assemblages can also stabilize the sediment. They promote biodisposition. They cycle nutrients through the water column, as well as contribute nutrients such as calcium from their shells back into the water column once they expire. Expired shells also contribute to habitat refuge for other aquatic macroinvertebrates and smaller fish. And they are also a food resource for many small river-dwelling mammals, some fish, and bird species as well. So in South Dakota, there has been no comprehensive statewide survey of Unionids. There have been about 15 surveys, and they have taken place between the years of 1915 and 2005, but they're all located east of the Missouri River. These 15 surveys were not uniform in methodology and were only occurred on particular areas such as counties or particular streams. So the purpose of our project was to actually employ the first comprehensive survey to look at distribution, composition, abundance, and to see if there has been any decline in species richness throughout South Dakota. Our second objective was to identify what habitat variables are driving assemblage variation. And our third objective was to identify conservation priority areas throughout the state. So like I said, our first objective was to implement this comprehensive survey. And we did this using the LORM 2012 methods. We had 202 sites proportionately and randomly allocated throughout 14 major water basins in South Dakota. At each site, we used a 2-person-hour search, which was typically a team of 4 of us researchers moving upstream and searching with our hands. Any empty shell or live mussel or fragment we encountered, we documented, threw it in a bucket, and recorded it. And all live specimens not kept for vouchers were returned to the stream. And these are our results. So on the left hand, you'll see East River, East Missouri River, and left hand is all basins, West River. We found the most rich and abundant basins, East River, with James being the most rich and abundant basin overall. We found 15 species, live and dead. All 15 were found East River, and we found 5 species West River. So we did 2 methods for historical comparison. This is the first one. We selected 7 particular sites from some historic surveys, and we revisited those exact sites. And we used this equation to calculate the change in richness per year. And this chart shows each of the 7 sites. As you can see, most declined, one stayed the same, and one, the Boise-Des-Sioux River, which is in the Red River Basin, actually increased. So we found more species there. Based on these 7 sites, we calculated an average decline of 1 species every 10 years. Our second method for historical comparison was basin-wide comparisons. So 11 of the historical surveys had specific abundance and richness counts for each site, which we compiled for each basin and compared to our surveys for each basin. We found a decline in every basin, but in the Red River Basin, again, we found an increase in species. So based on these 11 surveys historically compared to ours, we found a 50% decline in species richness. And overall, taking all 15 historical surveys, there was 36 historic species within the state, and we encountered 15, which is a 58% decline. This chart shows the blue bars are percent occurrence of current species that we found, and the gray represent historical species occurrence. As you can see, there's been quite a shift to three or four dominant species, which happen to be habitat general species. So they're not very particular about where they live compared to other species. They're typically dominated by the giant floater and the white keel splitter, and historically, the species compositions were much more even. So objective 2 was to identify habitat variables that are influencing mussel assemblages. This was done this past summer in 2016. We used adaptive cluster sampling with 50 random starts based on Smith et al. 2003 methods. We did this sampling at 44 sites where there was live mussels. When a live mussel was encountered, we took local habitat parameters, which are listed there, which included all the YSI readings. We had current velocity, 4 random substrate types, quadrat depth, and distance to the bank. And after the research was done, we took broad scale parameters found on GIS, which included level 4 ecoregions, land area for each basin, and the boundaries for each watershed. And what we found was average density was 0.15 mussels per meter squared, ranging from 0 to 56 mussels per meter squared. So you can see we had a wide variety of sites, or of measurements for all the sites. And we employed non-metric multi-dimensional scaling in PCORD to determine how sites were grouped together based on these habitat variables and density. And we found the highest correlated variables were substrate, particularly silt, fine gravel, and sand, as well as current velocity and conductivity. So these were the highest correlated vectors, potentially driving the mussel assemblages variation. Objective 3 was to find the conservation priority areas across the state. And this was a process done by McRae et al. In 2004, so we kind of copied their methods. So basically each site that we sampled was ranked into one of 4 categories: no conservation priority, low priority, medium priority, or high priority. And to be ranked into one of these, they had to meet at least 2 criteria for each site. So these criteria included number of species, the diversity index, number of individuals per species, and the relative abundance of listed unions. So there's 2 examples of sites up there. Site 1, as you can see, the criteria for each one is different. Diversity met the medium criteria. The individuals per species met the high criteria, and the other 2 met low criteria. Since there was 2 low, that site was ranked as low. Site number 2 had 2 criteria ranked as high and 2 criteria ranked as low, so it was given the high conservation priority rating. And what we found was that most of our priority sites were focused on East River, particularly in the James, Minnesota, and Big Sioux basins. And as you can see, the gray watersheds are South Dakota Fish, Game, and Parks aquatic conservation opportunity areas, which they defined are watersheds with high species richness, high human stress values, as well as most publicly owned land. So our sites roughly overlapped with a lot of their opportunity areas for conservation. So we found that mussels are declining overall. In 2016, we did find 2 additional species not found in our initial survey, bringing our total up to 17. So a decline from 36 to 17 species is still a 53% decline in richness. And these 2 papers are very good at explaining how human impacts, such as agriculture, is causing biodiversity loss. So what's happening is that the sediment from this tilled land is getting input into the streams, which is creating very silty sediments, such as seen in our PCORD analysis, because silt was our top driver of assemblage variation. So the mussels that are tolerant to that can survive in there. Also, pollutants and excess nutrients are being put into the stream, which creates conductivity, and that was another top driver in our analysis. And 60% of all waters in South Dakota of assessed waters in South Dakota are impaired, and the top contributor has been defined as agriculture. So what I think is happening is that these general species that we have found are able to survive in these impounded waters, and the species that are not tolerant to these changes have thus disappeared. Another factor to consider is their historical distributions. So we found most rich and abundant basins East River, and this may be in part due to the extent of the last glacier receding, which was about 10,000 years ago. And this glacier only covered eastern South Dakota. So when this glacier receded, it opened up all these new waterways for mussels to distribute. So they may not have distributed to West River due to time, hydrologic instability, or other habitat preferences that may not be available at West River. So overall, for conservation implications, I think that South Dakota needs to establish a long-term monitoring plan to assess any changes in their distribution or abundance throughout the state. Also, to focus conservation efforts, maybe on a spatially explicit subset of sites, such as those hotspots that we found for conservation priority. Obviously, maintaining habitat integrity throughout the whole watershed is very important to maintaining the stream's habitat. Preserving the remaining species that we have, so this could be done through reintroductions of species that can survive in these waters, as well as establishing a management plan for recovery and sustainment of unions. So this project is not done yet. There will be another graduate student coming in to survey public lakes in eastern South Dakota, as well as one of my lovely technicians, Kaylee, who worked with me this summer. She'll be doing an in-depth fish host analysis as an undergraduate research project. So this will look at if the fish hosts are available where the mussels are, to see if maybe those are limiting their distribution or decline. That's all I have. Yes.
Kaylee, can you describe in your methods that you spent 2 hours, is that correct, when you were at a site?
Yep, 2 person hours.
How, in the historic watersheds where you did your food sampling, did they use that same protocol?
No, all the methods historically were not consistent.
So is it possible that you didn't search long enough to find, so the declines in species, if they search longer, they found more, and if you search less time, you find less?
Yep, that is a possibility. I'd have to relook at those sites, but at one site though, we did find more species as well too, in the Red River Basin for that historical revisit. But I'd have to look at those old surveys to see exactly what, a lot of them didn't even have their methodologies listed.
I mean, that could be a issue
Yeah.
about standard protocols and getting something published if you don't
Sure,
know.
that is a good point to bring up, definitely.
How confident are you in the identifications that were of those mussels in those historical surveys?
That is another issue that I've read historically. Some mussels have been renamed since then. And so when I went back through the surveys, especially that one in 1915, it was hard to find the names then and what they are now. So there could be, some give or take on that as well. But for the most part, I'm pretty sure that they're what they are stated. But who knows what they did historically. Yes.
You said 60% of the assessed waters were impaired from agriculture.
Yes.
Do you know if most of those were East River or if they were spread out across the state?
That citation was statewide, so it's South Dakota Water Quality Assessment Report, so it was for the whole state.
I just didn't know if you had noticed that most of those were East River or West River, because I found it interesting that the impairment is from agriculture, but the species richness is higher East River,
Right.
where you think we would
Which-
have more impaired waters from agriculture.
Yeah, which could be part of too that glaciation event too. There's just more naturally East River, but they have decreased from 36 to 17 species. Neil?
Has there ever been a commercial fishery for mussels in South Dakota?
There was commercials. It was all mostly in the Mississippi River Basin, and I'm pretty sure they did some in Iowa and potentially South Dakota back in the late 1800s.
So that wouldn't have affected your
It-
populations within this time frame?
I mean, it could have. Because the streams used to be paved with mussels, and now it's so rare to find them. Yeah, Sarah?
Did you find any non-native species? And if you did you think that maybe that is affecting any native species abundance?
Sure. So the only non-native species extant in the state are the zebra mussel and quagga mussel, and those are limited so far to the Missouri River, and we did not encounter any within the state. So, yes?
Can you estimate the age of individual mussels?
The age?
Yeah.
We didn't age any, no.
But is it possible to do so?
Yep, you can, cut them like a
There's
tree ring.
destructive way to do it.
There's a what?
Destructive, you have to kill the mussel in order to do it?
Yeah, you can also take expired shells and age them as well. But yeah, the
Okay.
mussel would have to die.
Just think about the age distribution, whether you're finding a lot of old mussels that survived or
Sure.
younger mussels.
We
Yeah.
did find a juveniles, a lot this summer, we found a lot of juveniles, which is a good sign.
So how does the water quality and the waterways that you studied, do we have any more pristine waterways with regards to mussel populations? I'm just curious about what they do need in terms of the integrity of the habitat. You said maintain the integrity, but do we have to somehow, modify it or?
So you wanna know what
So what would be the pristine condition? So do we have another state, where are mussels doing well in the US or is this just a national problem?
well, the most abundant regions is down south, near the Gulf of Mexico. And I know that there's been a lot of papers published about their decline. Just the whole, everything you do in a watershed funnels down into the stream. And they are filter feeders, so they can bioaccumulate those nutrients, and they'll get smothered with the sediment. They'll clog their filters. So, unless you can go back 200 years and figure out what those streams were like and how many mussels were there.
So we don't have anything. So we know we just have to clean up our water essentially.
Yeah,
And then they'll do better.
We know what species what currently the streams are like. Like giant floaters, white-gills, floaters, fat muckets, they do great. We found most of our occurrence was of those three species. And they can survive in this type of habitat.
Generalist, right?
Yeah, the general species. Yes?
Can you comment about sampling 1 year on the species and then a following year on the habitat? How does the weather fluctuations in annual rainfall and other activities change the habitat parameters of the stream? Could you have, so for example, if you had a drier year, less stream flow, all those kind of things, is that valid to have habitat assessments in a different year than when the species counts were done?
So our surveys in 2014, 2015 were done on all perennial wadable streams. Mussels typically will not live in anything that's not perennial. They need water year round. And 2014, we experienced a little bit of a drought. 2015 was definitely a flooded year, and this past year was pretty regular, in my opinion. So we experienced all three types of flooding regimes. And the most extreme site we saw in terms of drying up was this site. So you can see the quadrat is 10 centimeters tall. And this was how shallow that was. We went to that site in 2014 and it was up to our mid-thigh maybe, and that is so low. And the mussels still survive there. And I'm sure that did change the current velocity a little bit. But they've been there for 2 years, 3 years since, so.
To your knowledge, has anybody sampled the stream every year, for 3 or 4 years to see how the habitat changes? Or does it fluctuate by year or not? Is that-
Well, every year will be different
I know, but has
hydrology.
anybody proven that see what I'm asking?
No.
Has anybody proven that the habitat remains the same or it changes with year? You want to get that?
Yeah, well, an extreme flooding event will definitely change habitat. But if there's water year round and mussels can survive there, because like this site, we sampled 2014, 2016. There's still mussels there.
Yeah, I'm not really asking about the mussels, I'm just asking about habitat. All the parameters, how do the parameters change by year?
Personally, I have not read a paper on that. I couldn't tell you. But I'm sure there's plenty out there about that. Yes.
So I was wondering what Sandy brought up. I was just curious about the flooding. And could the flooding help dispersal of the mussels into new areas? I'm just curious, how would they get around?
So the glochidia attach onto the gills or fins or skin of fish host. So if the fish host move more with the flood, then the glochidia, and if they have to land in suitable substrate. So if the flooding causes them not to be able to land if they keep recirculating the water column, they're never going to survive. Once they drop off the fish. But depends on where the fish go, that's where the mussels will end up, in certain habitat. Yes?
Has there been any consideration of possibly reestablishing mussel species that have been lost from a historic area?
In South Dakota?
Yes, or anywhere. Has there been that kind of research in terms of the ability to reestablish?
There was a paper that I read where they did do some reintroductions, but there are species that currently live there. It would be very hard to, so if the species is gone, there's a reason it's gone. And so if the habitat is not suitable, I don't think they would survive. But if you introduce like the giant floater to somewhere new where they can survive, that is a possibility. But in South Dakota, nothing of that measure has been done yet.
All right, let's give Kaylee a Thank you very much. All right, everyone, we'll see you next semester.